Good afternoon, everybody. So thank you very much for joining us today for the 8 Versa webinar on climate resilience. So today we're going to be looking at climate resilience primarily from the real estate and the built environment perspective, but it's worth pointing out that many of the relationships and concepts that we're going to discuss actually apply equally to all parts of climate resilience for companies, supply chains, and a whole broad range of different operations, which will all be impacted to one extent or another from the impacts of climate change. I know we have quite a broad and varied audience today, from building architectural designers and consultants right through to asset managers and people more in the kind of financial space. So my aim here is to really give you that overview and talk about the process and try and give you more of a practical guide as to how we might go about dealing with climate change and increasing our resilience in the real estate space. So my name's Chris Hocknell. I'm a director at 8 Versa, and I'm involved in many different aspects around the business and climate resilience, and particularly how we're going to make sure our buildings, our clients' buildings, and our asset portfolios are going to survive over the longer term, not just from perhaps a financial and climate resilience perspective, but how they're going to decarbonize, what's the operational cost, all those kind of things, all those questions that developers or asset managers might be asking, or designers might be asking. Our role is to really try and facilitate decision making and try and shed as much light on that as possible. So let's get into climate resilience. So we probably know the basics about this, and we've heard it increasingly more in the last, say, 24 months. This has really been rising up the agenda. Just as a rough numbers to kind of, I suppose, put out there, first of all, apparently the cost of adapting to climate change is estimated to be around 500 billion a year in 2050, and about $2.5 trillion of financial assets are expected to be at risk from climate change and inadequate resilience to this change. So that's the kind of quantum that we're talking there. And so what we're doing now increasingly is trying to understand more about how we can estimate that risk, put financial values on it, and then manage and mitigate it as best we can. So it's probably worth just going through 3 definitions. So sometimes these get used interchangeably, but these are the 3 key definitions that we tend to use around climate change and our responses to it. So the big thing is really for us at the moment is about adaptation and resilience. We've been working in mitigation for quite some time, and we know, I think most of us know about the many mitigation measures we're all undertaking in the respective areas of our professions and in the built environment around decarbonisation, retrofitting, designing for lower carbon buildings, etc. And now we're really kind of spending a lot more time looking at adaptation and resilience. And it's, broadly speaking, my opinion that with the right adaptation and resilience measures, that we can broadly avoid many of the impacts on the real estate and built environment space from climate change with the right approaches. It's not that it's not going to come without cost and a lot of energy and effort to do so, but with the right measure, we can become incredibly resilient. So a lot of this presentation, we're going to focus on how we would approach resilience in a more practical manner, and the need to really get into the detail, because the devil really is in the detail. Because what we'll find is, and we'll go through this in just a moment, that a lot of the methods that are used are kind of quite approximate. They use historic data, so they're looking backwards, which is fine, but really we're trying to some extent predict the future, and that requires a different set of tools and a different approach, and very, very small differences, changes and variables can make huge results in the outcome. So without understanding that, we don't really get to where we need to be. So I'm not sure if you are familiar with this. The there was a presentation by Stuart Kirk, and this was, I think, a few months ago, maybe June, July, and it caused quite a stir, and I believe it actually ended up costing him his job. And he's also made some other kind of feedback and comments on ESG. I would advise anyone that's on it's online to watch this presentation. It's only about 15 minutes. I would advise anyone to watch it. It's quite interesting, and he's quite a critic of I suppose the concept of climate resilience and value at risk. Now, I'm not saying that some of his limitations or shortcomings that he pointed out are incorrect. He actually made some quite good points, but it's just showing how this has become quite a hot topic, and there really is quite a big spread on what we should be doing and how we should be doing it. And I would say some of it is actually a little bit overestimated, and it's key to remember that the impacts of climate change and the need for resilience varies hugely geographically and hugely across socioeconomic boundaries. And for us in the UK, our adaptation and approach to climate change and climate resilience will be very different to other parts of the world. And in some respects, some areas might be completely minor and trivial for us, whereas they'll be very extreme in other places. So it is very context and geographically specific. And I think maybe one of the areas that perhaps this criticism or approach of this approach that Stuart Kirk brought out is very long-term, big macro. Well, it won't impact on company valuation long-term because investors are only looking 7, 8 years ahead, whatever it might be. Now, I think that's also a bit of a chronic problem with looking at the macro rather than the detail, because again, once we get into the detail, we see that there's a lot of activity and happening that we need to appreciate properly. So one of the things, the key concepts here, and this won't be anything new to any people from the investment and kind of asset management space. Really, this is the key definition here for value at risk. I'll just let you read that for a moment. So really, when we're looking at value of risk, we're really trying to quantify what the impacts may be of certain action, and obviously in climate change context, what will the impacts be of climate change on our particular asset, our building, whatever it might be. We're trying to look at what is the likelihood that we will lose a certain amount of money, or to how much money will we lose in the event of a certain outcome or happening. It's actually relatively easy to understand. It's just giving us a rough idea about the risk of an asset or a portfolio, and it can be usually measured in pounds or dollars, whatever it might be. One of the principles, if done right, is that it can be compared against different buildings. Different buildings can be compared against one another, and different portfolios, for example. And the idea is that we're trying to introduce as much comparability as possible. And I suppose this is really one of the things that we've seen in the last. So we've been involved in sustainability in the built environment since 2008, and what we've seen is that the conversation has really moved up the hierarchy or pecking order, so to speak, in the sense that originally, when we first started sustainability in buildings, we were really focused very much on writing the detail, and a lot of our conversations were happening at design team level or within the project team, one-to-one meetings with architects and perhaps developers or whatever it might be. And over time, the conversation about sustainability and the need for it and its importance has risen and risen, and now we're finding investors. As we know, the majority of construction projects, for example, are funded by debt, and well, investors now want to know what's their outcome going to be. We're having a multitude of different asset managers come to us when they're evaluating whether to procure a building, whether to buy an existing building, whatever it might be. This is now a key part of all of their evaluation metrics as to whether they should actually invest in the building. So it's now happening right at the very, very top of the financial kind of pyramid. And what we're finding is the buildings that aren't adequately adapted or aren't decarbonising or aren't having the right directional approach on sustainability are very quickly being cut from financial decisions. And we'll come on to this a little bit more, but this is where this is one of the aspects of where a value might be at risk, as well as the physical risks of climate change, i.e. flooding or heat stress is one one or two physical risks, but now we've also got financial risks of devaluation of assets and other things. So some of the challenges of value at risk is we can look at assets in isolation, which is fine, but we've got to consider that you might get feedback loops, and there's interaction between assets. You can't just sum up all the value at risk. If we look at what value at risk might be for a handful of different assets, we can't just combine them. We've got to look at it like when we're looking at portfolios where you have diversity and correlations. That's got to be considered, and that is incredibly complex. One of the key challenges we have, which will come on to the next slide, is lack of data. And there's a lot of uncertainty in a lot of these analyses because, well, first and foremost, we're predicting the future, which is a fool's game to begin with. But then we also have the complex matter of climate science and how that's going to manifest, the impacts of kind of countries, policy, and where we will be in 10, 15, 20 years time, which is almost impossible to predict. So all of these things all feed into our value at risk analysis. And at the moment, we also have various different value at risk methods, which, as I mentioned previously, interoperability and the ability to compare different assets in different locations and in different circumstances and contexts is very, very important. And if we can't do that, then we're going to really struggle. And at the moment, there are many different approaches, and maybe it's fair to say that there isn't particularly a right answer. So when we're looking at the financial risk of an asset, we're really looking at it in this, I suppose, this sequence really. So we start first and foremost from our perspective as kind of environmental scientists and sustainability professionals. We really start looking at, okay, what are the kind of the hard climate risks? That could be physical environmental risks, and then also perhaps how could they be influenced by policies. So that's where local and national governmental policies may be contributing or detracting or mitigating, whatever it might be. There are a whole range of different impacts that the correct policy measures can have, and that's also something that we've got to factor in here when someone's looking at buying an asset or developing an asset. Then they're now also looking at, well, okay, how conducive is local government or regional policy going to be in the climate risk of that asset over the next 10 years? Then we're looking at the risk exposure. Now, this is where the measurement and the kind of the ability to understand the correlations comes in. We need to be able to roughly estimate and understand what the ramifications are of certain risks and policies, certain physical risks and policies. How do we quantify that? How do we understand how that will manifest? And then finally, that needs to get translated into financial impact. And a couple of clarifications here. It's probably worth mentioning that uncertainty is really unknown probabilities. So we know we have difficulty measuring it. We can't really price it very well because we don't really have the data, whereas risk is more about the known probabilities, and it's really about we can measure it. There's a quality of measurement issue there, but it's also we can usually come to some kind of outcome with the data we have, and it's worth understanding the difference between uncertainty and risk in that respect. And uncertainty is really quite the battle, and as you would expect and probably know, climate change is absolutely full of uncertainty, which makes our job particularly challenging. The financial impact here can be manifest in various different ways. It can be on the valuation of the building, it can be its potential long-term earnings, and then is it actually going to appreciate or is it going to devalue over long term? So the different manifestations that financial risks and impacts can take. So moving on a bit more as to how we would actually go about something like this. So here we have a graphic of how we would actually approach and approach the climate resilience piece as trying to understand what the potential outcomes could be from climate change related risks. Let's give you a moment to just familiarize yourself with the graphic. So what we're really trying to do here is kind of undertake a real systematic assessment, and the idea is that it covers all aspects of the building and identify what impacts the changing climate will have over its entire life cycle. And this will include all of the physical related risks of weather conditions, etc., and heat stress, extreme precipitation, flooding, perhaps wind and drought, all those physical manifestations of climate change and how they relate on these potential outcomes. So, as our overall aim when we're supporting the likes of, say, asset managers and developers and ultimately kind of holders of built assets is how they can maximize, maintain the value, and obviously increase liquidity as much as possible. And this is the route and the approach that you would take. Now, one of the, we need to understand what the impacts might be of increased operational and maintenance costs of essentially fighting the impacts of climate change. If there's a once in a 20-year flood, something like that, what the impact's going to be, how severe is it going to be, and we've got some examples of how we would actually go about understanding that in the future. And this is all part of the kind of the analysis that we would do, and this all feeds into this overall strategy that the person who owns and perhaps operates a building would consider. And it might be that this is where we get the kind of the ditch or switch argument, where you might be kind of deciding whether you want to dispose of an asset because you look at it and you understand it has over the next 10 years to get it to a low carbon asset and to protect it against potential flooding in the area, for example. You might have to spend an enormous amount of money, and it might exceed the value of actually the rental income. There are these kind of issues and challenges that asset managers and holders of buildings need to understand, and that all of this feeds into this, and then they can work out what they're going to do with the asset. There are a variety of different tools that anyone could really kind of use. Some are paid, some are free. Naturally, the more high level and the kind of more what we call the framework, a framework of reference and a kind of an appraisal method. There are some free tools available there, and there are some very, very, very expensive pieces of software that users can purchase. So this is a screenshot of the kind of tool summary, and you can see the link there for anyone just to go and check out the list, and you can kind of filter by different applicabilities. There's also one for designers, surveyors, and architectural professionals, and the list is much, much larger. So wasn't able to fit it on, but I would encourage any building designers to go onto that link there at the bottom and just run the filter, and just you can see the different types of tools and how they relate. But you can see how these different tools, the idea is that they apply at different points within the life cycle, and the life cycle really is at the top there on that kind of x-axis from diagnose and conceive through to design, deliver, and then finally operating and maintaining. And naturally the demands, expectations, the data, and the calculations we need to take are different depending at what point we are at in that kind of procurement and in that life cycle stage. So this is quite a good one, which is a bit more focused on the I suppose the financial side, and you can see here roughly we have some data here about impacts on market value for an asset, and we can basically plug in the kind of data, and we can understand what the financial implications are going to be. And there's a link there for anyone who wants to know a little bit more, but just giving you a bit of a flavor as to some of the tools that are out there at the moment and can be used depending on what output you're trying to get and what analysis you're trying to go through. And naturally the kind of typical approach would be that we would look at different climate change scenarios, business as usual, versus some kind of reduction right down to kind of 1.5 degrees, which would be the science-based targets and the kind of the COP aspirations, and what impacts would each of those scenarios have on our asset. A free one here for anyone who would like to just kind of see, I suppose, more of a framework and a tool which kind of tries to quantify exposure and risks a bit better. So this is worth reviewing just for your mind's eye. There could be some things on there which perhaps maybe didn't occur, but this is a good point of reference, and it's obviously free because it's the UN, but it's aligned with SDGs, so it's quite useful. There are a whole different range of different tools, and with varying merits and application. But one of the key considerations and perhaps shortcomings that I'd just like to, I think, really important to draw upon is that many of the tools are really good at one point within the phase, or have relatively detailed data, and maybe are weaker in other areas. So as we'll come on to in the coming slides, you will see that a lot of the real impacts as to which, and a lot of the analysis which you would need to make as a building designer, or as someone who's really working out if they want to invest in this asset or not, it's all in the detail, and it's all really kind of very specific to locale, to context, to geography, and all those kind of things. And it's worth in our estimation that a lot of the tools out there are really good for that first screening. What we would tend to split it into two steps, two sequences. First is screening, and that's identifying. So that's kind of a bit of your high level sense check. What does this building asset look like in terms of its climate resilience and its risk profile? And then if we flag any areas of concern or any kind of suspicious looking items, then we would qualify that for a deeper dive and getting into the data and getting into the detail. And it's really important that any decisions that could or would be made must pursue the that kind of deeper dive and that analysis, because the truth is at the moment that none of these tools can do everything. There's just too much. It's just too complex. They're good tools, but you've got to know how to use them, and you've got to be able to overlay the addition of that kind of expert opinion. So this is a bit how we would approach it and how we approach it. So if we're looking at a real estate portfolio, we have a whole variety of different data points and inputs that we would actually take from that portfolio. Really key information. It might be a lot around geography, kind of certain aspects around about the local kind of the boundaries, what's adjacent. It could be other aspects related to the age of the asset, a bit more about it. We would run that through a screening calculation. We would get some outputs, and we would identify which assets are most pressing for that particular asset, and start to really kind of roughly estimate what is the impact going to be of that risk. And that's when we get that second step, we get that output. So we get some output from our screening calculation, and this is where you would use something like those tools that we just showed on the previous slides. That will be some of the outputs you get there. And that's your first step. Those first two boxes, that's your screening calculation. That's your overview. And then what comes next is the level two. This is the deeper dive. This is where you kind of really get into the detail. And this is where you need an expert or a professional in a particular kind of area of expertise to really do a more in-depth hazard assessment and evaluate the risks, probability and impact. That's the key things that we're looking at here. And also considering the time horizon as well, because naturally the risks out from 2020 to 2030, out to 2040, 50, etc., are much greater and much more uncertain. So we got to weigh up and balance those kind of trade-offs, and that is where you need that expert risk evaluation and assessment in the detail of the hazards. Then once we've done that, we've kind of added that overlay of more detailed deep dive, which is much more specific to that asset rather than a high level rule of thumb benchmarking exercise. We've gone into the detail, we get the detailed outputs there, and that's really right down at the building level risk review and a detailed mitigation strategy and plan as to what we need to do exactly to mitigate the impacts of that of climate change on that asset. So once we've gone through that process, we've got our kind of key outputs there. We've got a plan. What do we actually do with them? We need to understand prioritization and influence. And this may be something that you may have come across in energy efficiency and the idea of decarbonisation. So this is what's called a MACC, and that stands for a marginal abatement cost curve. And this is very much, as sustainability professionals, our bread and butter. This is the sort of things that we're doing when we're looking at how easily can buildings decarbonize. So if we want to get to a net zero in operation by 2030, perhaps 2035, whatever it might be, how can we do it and what's the cost? And basically the principle of this is obviously on the x-axis, we have how many tons of carbon we abate. So obviously the wider the bar, the more tons of carbon we're abating, and then basically the taller, the higher the cost. So in this particular instance, we can see all those measures on the left, which are usually around energy efficiency, energy conservation. They're below that line, so they actually pay back. So thank you very much. It's cost positive, so that's great. And particularly it's worth noting that in the last few months, with all of the energy price madness that's been going on, it's worth revisiting many of our kind of original appraisals, assumptions, and decision-making criteria against which we chose whether to do or not to do certain energy efficiency measures, because the economics have completely flipped. PV, solar panel installations, for example, may have had a payback of 10 years. That could be 4 years now. So there's, in so many aspects and so many ways, we've been over the last 10 years, we've predicated energy efficiency measures on certain logic and certain kind of data points and cost assumptions. They have really changed, and in many ways, the capital cost of measures has gone down, PV being a key example. It's now a third of what it was 10 years ago in terms of the cost, and now energy prices now 3 times plus what they were. So this is worth revisiting and reconsidering. But when we're looking at climate resilience, the approach that we would take is very similar as well to, say, this kind of energy efficiency approach, which is we line up all the options we could see being relevant and kind of consider as achievable for this asset, and then naturally we start with the most effective ones on first, and then we build up to the most expensive and least kind of effective ones. And one of the key things of doing a marginal abatement cost curve is that we need to layer the options. So we might look at, say, okay, so we make change number one, we make measure number one to improve the resilience. Okay, what happens when we do change number two? So we got 1 and 2 combined. Then we have 1, 2, and 3, and adding them together and having that, seeing what the marginal again is each time. That's absolutely crucial, because we can't just look at measures for climate resilience, much like energy efficiency. We can't just look at them in isolation. We need to look at them as if they were packages and they were done together, because they have relationships and kind of impacts on one another. So this is really the kind of process that we would go through, and hopefully for those of you who have looked at decarbonisation and a method of prioritising energy efficiency using tools such as this marginal abatement cost curve, you will appreciate that we would use the same logic again when we're looking at climate resilience measures in terms of prioritization and quantifying the ability to mitigate climate change. Okay, so what might that look like? And this is just worth considering how some of the policy impacts are being felt up and down the country at the moment. So, for example, we have here this is our distribution of EPCs in England and Wales, and you can see this is a normal, roughly a normal distribution curve, but very few A's and not that many G's and F's. And then the average EPC rating in the country is around a D. So from a climate resilience risk, policy risk, what risk might that pose? Well, what we could see, and there's some data and there's some very recent data that's come out recently, just quantifying the benefit that's being manifest in sale prices and rental values of, say, a BREEAM Excellent office or buildings that are seen to be greener. And it's kind of more and more. We've got to kind of treat some of it with caution because there's obviously a lot of vested interest, but more and more the data are showing us that there is a premium in the more sustainable buildings, which is exactly what we want to see. One, that price signal, and increasingly we're seeing devaluation on the lower end. So in the middle, that kind of DC band, I think is kind of, we haven't seen much change there. It remains to be seen whether that kind of premium valuation at the top of the pile and the devaluation at the bottom starts eating in to the middle of the distribution. But at the moment, this is what we're seeing, and this is one of the key drivers around it. And this is the UK minimum energy efficiency standards, the UK regulations. So you can see here minimum EPC ratings, and F and Gs are now were kind of from April 2018. You could not let out any new property if it was an F and G. As of next year, that applies to all existing tenancies. And the idea is that the government will progressively tighten these regulations. So that kind of point of devaluation there will creep up and get higher and higher. And the aim is to get up to B by 2030. So naturally, you can imagine if you're about to purchase an asset and you find out it's a D-rated building, and or whatever it might be, whatever rating it might be, and you find out in 2-3 years that you're going to have to rip out the heating system and install a new one to get it up to the requisite level, you need to be subtracting that from the sale price, and that's where that devaluation is going to come in, and that's where you need to understand your kind of longer run policy and regulatory exposure, and what measures we're going to have to do, what changes we're going to have to do to that building to get it into compliance, to get it more resilient, or to whatever it might be, and how much is that going to cost, and how effective is that measure going to be. So I just want to kind of move on now to just looking at the importance of some of that deep dive analysis. So this is a very good tool that we've used for our screening calculations, and you can see this is how it does the overall risk assessment of an asset. So you can see here we've got that kind of color coding from low risk to higher risk, and we might look at kind of key areas of physical climate change risk, and that could be heat, precipitation, flooding, drought, wind, etc. And naturally, when we're looking at different scenarios, the business as usual scenario is worse, and then we've got the future 2030 and 2050 scenarios, and then the impacts of climate change being more felt. So naturally, as you can see, as you go along the timeline, you get more reds, you get more medium and higher risks occurring. But this is just a screening calculation. I just want to show you how. So this is our screening calculation, and this is an asset in the north of England that we were looking at, and that yellow area is the flood risk zone, and you can see there the asset looks quite nicely located. Not too much of a problem there. And this is using macro big picture data. It's one of these fabulous tools. Will do lots and lots of things, but you know, like most tools, if they can do many things, they're usually not so good at doing some fewer things in a much more specific and deep dive way. So that's our screening calculation. We overlay what we know as professionals, looking at alternative sources, particularly flood risk, and what could the impact be. And then we discover that it's, say, 50 meters away from a flood risk at level 2. So, and that's based on current weather data and topographical data available from the Environment Agency. So again, this is the importance of aggregating the data sets, having a different more data to draw upon than just one tool in the toolbox. We need to understand, you know, which tools do what best and use them effectively. This is another building. This is in London, and this is a building where we're looking at what is the climate change risk to this building in respect of flooding. As you can see, it's very close to the Thames, and there's also a very small river running by it. You can see that building B there and that little pink line to that dot. So we can these little points are basically modeled flood breaches for the respective rivers, and we first got to understand what the risks are right now, and then what the site specific risk might be. So this is a site contour map. So this is taking actual data for topography. You can see here the elevations, or the kind of or rather the contours. So this are the levels of maximum likely flood levels. So we can see here that if the river bursts, or if it floods, what levels of surcharging, so depth of water, will we have across the land. So this is something that wouldn't have been pulled out in the general map, in the general kind of high level maps, but we can see here we would have approximately 20 centimeters plus of water levels across the site. So therefore our first recommendation is that if you're building on or developing this site, then you need to raise the floor levels by at least 300 millimeters to mitigate this risk. Or if we're looking at an existing asset here, we will say the likelihood is in the next 20 to 30 years, you will experience a flood of this nature, and at 30 centimeters deep flooding, the impact on this building will be X, and the cost of remedying that will be Y. And this is why we need to dig into the detail, because the devil is here, and we won't be picked up in high-level screening calculations. Another one just showing the impacts of climate change, and this is just to show why it's important to look out to the future, really. So we can see this is our modelled flood level for that same site, and you can see here this is in 2020. We can see everything that's black is where the flood level would be. Let's add our climate change allowance, so the impact of climate change. So as a quick rule of thumb, the kind of rainfall and consequential flooding risk is usually around 40% higher when you factor in climate change. So you can see here, when we factor in our climate change scenario, that site goes well into the flood zone and will be at risk of flooding purely as a result of climate change impacts manifesting themselves. Now, the black is a low water level, and white is a very deep water level. So you can see here that again we've got kind of much deeper flood risk here with the overlay of climate change. Overheating is another one. Flooding is really important, particularly in the UK context. That's probably the biggest kind of climate change risk, and then equally or perhaps secondarily is heat stress and overheating, as I think we can we know what it's like given the last month or so to kind of have that heat stress, which can be quite a challenge for many different types of people. We can see here this is just modeling 3 different design years. So the data aren't too important, but you can see here we have in our kind of main column just after the rooms here. So this is a residential scheme in London, and we got DSY 1, 2, and 3. So these are basically more increasingly intense heat waves and heat stresses, and this is based on current data. This is basically a heat wave within the current scenario of climate change. If we're looking at 2030 or 2050, it would be even more extreme. But the key thing to note here is that the difference between just a normal, moderate, average warm summer, we have compliance in this building, everyone seems happy, and no one's overheating. Where if we go to a heat wave, a long, intense heat wave, something like we experienced relatively recently a few weeks ago, you can see that all of the rooms, most of the rooms, probably about 60% of the rooms are failing their comfort criteria. They're under extreme heat stress, and they're experiencing very, very prolonged hours of exceedance. So one example would be if you take that top line, for example, under the moderate warm spell, one room in particular spends about 18 hours above the comfortable range, and now that's up at nearly 60 under the kind of the warm longer spell, very similar to like we've just had. So you can see what difference that makes, and this is something we need to be considering. And this is just, as I want to stress, this is just 2020. This is not future. So this is sort of thing we need to be considering as well, because obviously to mitigate heat stress, you may have some tools in your toolkit, to mitigate that. But more often than not, retrospective measures to reduce heat stress and overheating can be very expensive and very costly and very disruptive, which again, this is something that would need to be considered and even detracted from the value of a property if it needs those kind of deep remedial measures. So this is guidance that I would just like to, a bit of a, I suppose, a crib sheet for designers, people who are involved in the kind of the construction and retrofitting and refurbishment of buildings, but then also for any asset manager, any building owner operator who's just trying to appraise a building for its broader kind of climate resilience potential and its risk. So these are what key areas to look at if you had to do it, if you had to dig in and understand what does this specific asset pose as a potential risk. Now, some of these are quite obvious, but you might think, well, passive design measures, yes, that's okay. That's just heating and shading and those kind of things. But one of the key things we need to consider is we need to model wind patterns. We need to know the detail. What's the flooding going to be like in now based on the average storm versus 2030 plus. Number 4 is particularly important, is flexibility, and this is something that's probably quite often neglected. We tend to maybe look at buildings as very static and immobile, and that's kind of understandable. But understanding how flexible a building is quite important, because to the untrained eye, I suppose, two buildings can look very similar, and you might just say, well, okay, it needs this change or this change making to it to make it climate resilient. Well, some buildings, depending on their construction type, their design, and many other different factors, are much better at incorporating changes than others. Much less cost, much less technical challenges, fewer technical challenges. So understanding how flexible a building is, which is something that can be hidden, can have another big impact on the cost and the implications of retrofitting and such things. Other things which might be a bit more obvious are something like the albedo. So obviously lighter surfaces will reflect and absorb less infrared radiation, so will be cooler. Vegetation, the access to green infrastructure, how close is it? Do you have any on site, which will help reduce heat island, keep the users happier. And then also another one which is often neglected is the influences beyond your boundary. So you're looking at one asset, one site, one car park, one building, that's you. Well, you need to be looking at the localized conditions. Do you have a great big building overshadowing the other building, which will actually massively reduce potential for heat stress? Are there certain things going on in the assets or buildings around you that might make your climate vulnerability even worse, exacerbating flooding? Are there certain, is there a basement nearby? Are there, all these different things, which again, you can't just look at. You can't pull out from looking at a high-level screening calculation. You need to look at the specifics to understand what relationships and influences the local assets around you might have on you. So this is I suppose our 5 key recommendations brought more broadly as to where we need to go to maximize climate resilience and what we should all be aspiring to achieve. We really need to make sure that climate change assessment and evaluation is really a standard part of any kind of building portfolio or any kind of building purchase, because it's crucial. And if you're looking at holding an asset for 10 to 15 years plus, well, obviously you're going to experience impacts of climate change, and you're going to need an adaptation strategy there. Number 2 is crucial, which we've been trying to kind of pull out here, is that big difference between the screening, the high level overview, and then the deep dive into the data, which is where you will find out if your building really can adapt well or not, what the cost implications are going to be, and you can't make any real decision without that deep dive. It's really important to stress that. We don't have good enough data right now. The tools are doing the best they can, but we can't do everything. So we need to build up more and more data. And I think the more professionals collaborate and we share data, the more we'll be able to build up better risk data and understand that better, to model it better. And then we obviously all need to be working in and around decarbonisation, and where possible, incorporate as many hard resilience measures as possible. So ones that are effectively passive and don't need the input and the maintenance as such of people, and are just built in and baked into the building design or operational strategy, whatever it is. So kind of passive, hardwired resilience measures which anyone can use and just happen to lend their benefit. And then finally, I think recognizing that if we do this properly, that we can actually add value. And I think this is maybe the something that's maybe overlooked a lot, because in reality we tend to kind of look at all this in doom and gloom and kind of in a detractive and negative manner, which, you know, to some extent it is. But you know, we're actually in the position where we can add and manifest a lot of value for investors and for users and for tenants. If we get this right, we can be working with the more far-sighted and kind of developers and asset managers to make better buildings that will withstand the test of time and will be more resilient and provide a much better service for their users in the longer term. I think that's a really exciting place to be. So thank you very much for your time and for listening, and we have some minutes left for questions. So if there are any questions, I would welcome some. Thank you.